Love to see it. So anyway, not going to make that mistake again. Okay, so 2.6, laws of logs, still stuff with logs. Again, your quiz tomorrow will be over 2425. So not 26, 2425. Okay, so stuff you guys would have done this past homework or this past weekend for homework, and then also what I assigned on Thursday. All right, so we'll do some just very basic properties of logs, and then we'll do some properties of logs that I'm assuming you guys have seen before. All right, so first of all, for all logarithms, log base b of 1. What would log base b of 1 be? And remember, you can think about it this way. A logarithm, like a big thing you got to keep in your mind, is that a logarithm is equal to what? What does the right side of that equation represent when you have a log equals something? The exponent. Like that's the thing that's got to be living like rent-free in your head. A log is equal to an exponent. A log tells me what exponent I need to use, okay? And if you think about it like an exponential, obviously log base b, like this is the base of your log. So what exponent would we need to raise b to in order for the output to be 1? It's got to be 0, okay? So when I'm chasing after an exponent, you need to think, okay, the end result is inside of my log. What exponent would I have used there? In this case, it's going to be 0, okay? What about log base b of b? What exponent would I have to raise b to for it to equal b? Yeah, so those are just very basic properties that should be pretty obvious why those are true, okay? All right, and then, if we really wanted to, we could rewrite each one of those expressions as an exponential. You guys do really well with exponentials. But let's just move into our laws of logs, okay? All right, so in all of these cases, m, n, and b are positive real numbers, and b is not equal to 1. And then k is going to be any real number. So these properties here are properties that I used over there, I imagine you guys have seen before. So this, I don't necessarily like the way this is written. Plus, it's got this here. Can I, get rid of that? I don't think I can. So I'm going to rewrite it first, just so you guys can clearly see what's going on here. It's b to the exponent of log base b of m. Okay, so I'm going to rewrite it, just so you guys can clearly see what is going on there. So b raised to the exponent of log base b of m. I need to rewrite that with LaTeX. That's what needs to happen. What is that equal to? Anybody remember? M. Yeah, the b to the log base b cancels out, and I end up with just m. Good. Okay, so these are what we would call our inverse properties. Okay, and then what's going on with the second one? That one's pretty well written, but log base b, and then inside of the log would be b to the power of r. So I think I wrote that property right here, but instead of b, I used a, and instead of r, I used x, but we would say that this is equal to r, okay? So these things cancel out. If you have log base b of b to the r, think about it. You're searching for an exponent. What exponent would I need to use to raise b to the power of r, to get b to the r? Well, it's just going to be r, okay? All right. And now what we have, what we would call our product, quotient, and power properties, okay? Next year, we're going to call them, well, not these, but we're going to use the product rule, the quotient rule, and the power rule, but we'll do that with derivatives, okay? Now, these are kind of like the opposite properties of our exponentials, which we'll talk about as well, too, at some point. So log base b of m times n. Does anybody remember how I can expand that or split that up? So if you have two things multiplied by each other inside of a logarithm, we can write it like this. Log base b of m plus log base b of n. So when I have two things multiplied inside of a log, I can split them apart using addition, or three things or four things or whatever, okay? And then what about for quotient property? How am I going to split those up? Subtraction, good. So log base b of m minus log base b of n. All right. And then let's do our power property. So this one is probably one you guys have seen before as well too. But if you have log base b of something raised to an exponent you can take that exponent and toss it out in front. So that would be k times log base b of m. Maybe this isn't written clear enough. If it's not written clear enough for you, this looks like log base b of m to the power of k. Okay, so if that's not written clear enough for you, that's what that should be. I need to take my time and go back and do it with LaTeX, because then I think it'll be much easier for you guys to see. Okay, but otherwise, if you have an exponent, you can take it and put it in front of the logarithm, which is very handy. Have we seen these before? Yes. What's important is that you guys also realize that these properties are biconditional, which means they go both directions. Okay, so like we are used to taking things from left to right. If we go from left to right, we would call that expansion or expanding. You guys remember expanding and condensing logarithms? You guys remember doing that in the past? Maybe not. If we go from right to left, that's also true. Condensing. So if I have two logs added together that have the same base, but the argument on the inside is different, what I can do is I can condense that into one logarithmic expression where those two things are multiplied by each other. Okay? So big thing, those properties are biconditional. Some problems will ask you to expand your logarithms. We'll go from left to right if we're looking at these properties. Other problems will have you condense the logarithms, so we'll go from right to left. And eventually when we solve equations involving logarithms, it's very helpful for us to condense logarithms together so that we may solve it by using exponentiation. I will highlight that word every time I say it. Suddenly I'm speaking in caps lock. Okay, so let's do some easy expansions using properties of logs. So natural log, this one's for Hannah. Natural log of x squared times y. Doesn't matter the base of log, natural log, common log, log base 2, doesn't matter. All these properties still apply. All right? What rules, product, quotient, or power, would you expect me to use for that first one? Product, why? Yep. What else? Well, go ahead, Charlie. What else? Probably the power, because that 2 is there, right? Now, the key is that 2 on everything? Just the x squared, or just the x rather, right? So we got to be careful about where we put that 2, okay? All right, which rule do you think we should use first, power or product? There is a certain order that I do need to do this in. Probably product, because again, that 2 is not on everything. So I would first start by writing it as natural log of x squared plus natural log of y. So I have 2 things multiplied by each other. I expand them using that product property. And then we're going to use that power property that Charlie was talking about. And I'm going to take that 2 that's on the x, and I'm going to toss it in front of just that logarithm alone. So that becomes 2 natural log of x plus natural log of y. Suddenly, crayon. Okay? All right. What rules would you expect me to use for the second one? Quotient for sure. Also power. Which one do you want to use first, Andy? Quotient first. Good. Because that square root is not on everything. It's just on a. Okay? So then we would have log square root of a minus log b. And then what do you want to do, Andy? And toss it out in front? So 1/2 log A minus log B. We okay with that? So square root is the same as 1/2. So then I'm just going to make it, if I did that step that Andy was talking about that I probably should have, it'd be log A to the 1/2 power, but I'm going to toss that out in front. That's how I get that guy right there. Okay? All right. Let's go the opposite direction. How many of you have an interest in engineering? I'm sure a couple of us in this class, maybe. If you want to be a good engineer, not only do you have to take things apart, you got to put them back together as well too. So let's learn how to put things back together using condensing. I think my middle daughter is going to be an engineer. She likes to play with circuits. You guys ever see those like circuit kits for kids? So she's 5. She put the instructions in front of her, and then she just built the circuit by herself. And I was over the moon about it. I was So impressed. All right, so log base m of x plus 2 plus log base m of x. Because I have the same base and I am adding the two logs together, which rule would you expect me to use? I'm going the opposite direction now. Now I'm going from right to left. Product, right? Because I'm adding two logs together so I can combine them using product, okay? So here's how that looks. Log base m, and then I just need to multiply the two things inside the log. So I'm going to first write it as x times x plus 2. That's sufficient. If I want, I can distribute, make it x squared plus 2x. Now, I should note this. When you have log, and inside the log there are two things added together, you cannot split that up using any one of your properties. It is if and only if the two things are multiplied by each other. So like these two things I could split apart and it would just be this. That's expansion. That's just opposite of what we did. But if it was just log of x plus 2, there's no splitting those things apart. You can't split addition inside of a log apart. Okay? All right, what about for the next one? Log base 2 of x over 3 minus log base 2 of 5. What properties would you expect us to use in this situation? Charlie? Quotient for sure. Got that subtraction sign as well too, right? But then log base 2 of x is over 3. I personally think it'd be easier if we rewrote that somehow. If we rewrote that somehow, I think it'd be easier for us to see what we need to do. How could I write log base 2 of x over 3? How could I rewrite that?
1/3.
I like that. 1/3 what, Amog?
Log base 2.
Yeah, because then it looks like that 1/3, mathematically equivalent, but now it looks like a coefficient, right? Instead of dividing it by 3. And then when we write it like that, that should probably remind us that we're going to use what other property? Yeah, the exponent, the power property, right? Which one do I do first? There's a correct order in how to do this. And it's not the same every time, but in this case, which one should I do first? Power. Because that 1/3 is not in front of each one of our logs. Okay? So I should pull that up first before I divide them using quotient. So log base 2 of x to the 1/3 power minus log base 2 of 5. And now I am able to combine them using quotient property like Charlie said. So log base 2 of what? What goes inside of my log?
X to the 1/3.
X to the 1/3 over 5. So it should look like that. One of the most common mistakes that I see pre-calc kids make is from this step here to here. Do not do this. I'm going to write it in red pen. Do not do log base 2 of x to the 1/3 over log base 2 of 5. Yes, you divided two things by each other, but that's not right. It has to be log of one fraction, okay? So this is no bueno. Do not do that. Do the other one. The other one is right. Log base 2 of a fraction, okay? All right, those are the easy ones. You guys ready for the hard ones? Yeah, let's put the pedal to the metal. All right, so we've got a lot of stuff going on here. Log base A of a whole bunch of crap. Not crap. A whole bunch of good stuff. So we want to expand this, and then we'll condense the following one. Oftentimes, it's worth our time to rewrite things. So how could I, like, do you guys want to do a rewrite for the first one? What do you think? Yay? Nay?
Yeah.
Yay. Okay. How could I rewrite the first one? What should I do? I just now took attendance, but I bet they still knock because they probably sent them out before I did it. What should we rewrite? Top or bottom? I'm thinking the top. So if we want to take a moment, which I think would benefit us, switch back to, oh no, we'll go to blue. It's Guardians Day. Log base A of quantity x squared plus 2 to the 1/3 power. We okay with that? Set a cube root. My denominator, there's not much I'm going to change. Okay, you guys tell me, which properties are we going to use? I'm thinking all of them, right? There's a lot going on there. So I think we need to use all of them, okay? All right, now let me ask you this. How many log expressions will I have? Like how many log terms will I have? What do you think? Up top, I have quantity x squared plus 2 to the 1/3 power. And the bottom, I have x to the 4th times quantity x plus 2 to the 3rd power. Well, and I expand this out. How many logs am I going to end up with? Michael? You said what?
3.
How many of you guys agree with Michael? And Michael's pretty smart. Which one's like, okay, so x squared plus 2, that's going to get its own log, right? But that's only going to get one of them. Because I said the x squared and the plus 2, like, I'm not able to split those apart, okay? X to the 4th will get a log, as well as quantity x plus 2 to the 3rd power. So those were all 3 of the logs are going to come from. All right, we're going to use every property. Which one should I use first? Charlie? Take a guess, pal. You got a 33% chance. Not the power. Quotient. And I'll show you some instances where you would use power first. I'll make up an example after this. Why should we use quotient first, Colin? What do you think? I mean, you're right. And it's kind of hard to articulate why.
Because you have the division between the two terms, and you can't really do anything else without getting rid of it.
Yeah, like I can't use, like the reason why I can't use power is because, you know, it's not all of one thing to the same power. And I can't use product because that's only happening in the bottom. But I can split the top from the bottom apart and then go from there. So I like that. Okay, so then we would make it log base A of quantity x squared plus 2 to the 1/3 power minus, and then I would do log base A of x to the 4th, I'm going to put this in parentheses, times x plus 2 cubed, rather. All right, so that's split top from bottom right there. Okay. All right. Now, what do you guys want to do next? We could just focus on one term at a time. What am I going to do with this term? What's the only thing I can do with that term? Power. Pull that 1/3 out in front, right? So then 1/3 log base A of quantity x squared plus 2. There's nothing else I can do with that. That square that's on that 2, it's not on everything that's inside of the log, so I cannot pull that 2 out, okay? Since these two terms are added together, there is no property of logs that allows us to split when things are added inside of a log. Multiplied, for sure, but we can't split apart when two things are added or subtracted, okay? All right, now, over here, what property do you guys want to use next over here? Your options are power or product. Product, because not the same power is on each one of those terms. But I have to be careful, because when I split this apart, there's subtraction in front of it, right? Because normally I would split these apart using what? Addition. But this whole term is being subtracted. So there's one of two ways I could do it. I could write it like this. Keep that subtraction sign there. And then put a parentheses, log base A of x to the 4th plus log base A of quantity x plus 2 cubed. So we could do that, right? That's just one like simple property that we use. But in my next step, I'm going to distribute this negative or this subtraction sign to this term right here to make it also a subtraction sign as well too. Okay? Or think about it like a -1 that you're distributing. Okay? All right, my last course of action here is I want to put these exponents in front of their respective logs. So then I'm going to put a 4 in front of this one, a 3 in front of the second one, and I'm going to distribute that subtraction sign. So then I would end up with, still my first term, 1/3 log base a of x squared plus 2. And then minus 4 log base a of x minus 3 log base a of x plus 2. So again, these exponents are going to come out in front. And I have to distribute that subtraction sign right there as well, too. So that's what I would end up with. All right? Are we okay? Okay. If I had this, log base b of the cubed root of x plus 2 over whatever, y, I don't know. Then in this case, which property would I use first? I gave it away. Power, right? Because all of its raised to the 1/3 power. So in this case, I would pull the 1/3 out in front, and then I'd have 1/3 log base b of then this expression, and then you would use quotient to break it up, and each one of them would have a 1/3 in front. Does that make sense? Do we want to see that? You all right? Okay. You guys are eerily quiet today, so I just can't tell. All right, let's condense into a single logarithm. We have 21 log base 3 of x, cubed root of x, plus log base 3 of 9x squared, minus log base 3 of 9. So now we're going the opposite direction. We're condensing. Which properties do you see us using? All of them, right? I have numbers in front of my logs. I know I'm going to pull them up as exponents. And then I see logs being added and logs being subtracted. Okay? So we're going to use them all. Which one do you want to do first? Power. Okay. I like it. Each one has its own individual power, so let's do that, except the last one there. All right, so log base 3 of x to the... Help me out with this first one. How do you guys want to handle that first one? It means the cubed root... That's a 3. It's the cubed root of x... Brother. But now to the 21st power. Can I simplify that? I can, right? All right, I'll do that next step. Plus, well, I guess there's nothing that I can necessarily do with my next two terms, right? Because those don't have powers on them. All right. What do you guys want to do next? What can I do with this term right here? What can I do with that exponent? Hey, awesome. Thank you so much. What would that exponent become? 21/3, right? Because it's the cubed root. Are we okay with that? 21/3. What is 21/3? 7. So that's going to reduce to 7. Okay. So again, that's log base 3 of x to the 21/3. But really, we can just change that to log base 3 of x to the 7th power. Okay. All right. Plus, I'll just write my other terms, and then we'll just go slow and simplify them here in a second. And minus log base 3 of 9. Okay. All right. So now I'm ready to condense it, right? We can, which one do you guys want to combine first? The first two or the last two? Let's go the first two. So then it would be log, we can really do all of them all at once, but we'll save that. So it'd be log base 3 of x to the 7th times 9x squared minus log base 3 of 9. All right, but I can combine those things, yeah? Log base 3 of 9x to the what power? 9th minus log base 3 of 9. And then after that, I can just condense them using division, right? So what's that going to look like? Log base 3 of what? Yeah, it'd be 9x to the 9th over 9, but you guys already canceled those 9s out, right? So it'd just be log base 3 of x to the 9th power. All right. Questions there? Okay. We're going to pick up the pace a little bit. All right, so if you have two things equal to each other, then you can take the log of both sides of that equation. So if you have m equals n, then log base b of m equals log base b of n. However, that works both directions. So if you have log with the same base on both sides of the equation, and it's only log base whatever of something on each side, then you could also work this direction and get rid of the logs and say that m equals n. And that's what step 7 shows as well too. If log base b of m equals log base b of n, then m equals n. All right, so to solve the following, check for extraneous solutions. We have 2 times log base 4 of x equals log base 4 of 16. In order for me to use those properties though, log has to be solved for without anything else around it. So like I can't just drop the logs for that first one right away. I need it to be just log base 4 of something. So what should I do with that left side? Pull that 2 up, right? So log base 4 of x squared equals log base 4 of 16. And now that it's log base 4 on both sides and there's nothing else there, I can drop the logs using that property that I showed you up above. Or you could think about it like exponentiate both sides with a base of 4, and you would get x squared equals 16. All right, so then I'd solve for x, and I would get x equals what? Plus or minus square root of 16, which is plus or minus 4. However, what type of numbers work with the domain of log? Yeah, just positive numbers. You guys hopefully remember that from Friday. But we cannot take log of a negative number. So because of that, my only answer is going to be x equals positive 4. So that negative will not work, and I just get x equals positive 4. Okay? And I could check that by if I plug positive and negative 4 into my original equation, can't take log of a negative number. Okay? All right, the middle one, log base a of x plus log base a of x minus 2 equals log base a of 4. Amog?
Oh, why can't you take log?
It's an inverse of an exponential. So an exponential looks like this. Its inverse, which would be reflected over the line y equals x, is going to look something like that. So log doesn't work. Like we can't have a negative number inside of our log.
Like if you put it in the equation, will it still be possible?
So if we have like log base 4 of negative 2, is that what you're saying? Your calculator is going to get really mad at you if you try.
But like what if the base is negative?
You won't have any with a negative base.
That's just not possible.
Right. Yep. Yep, we won't do any with a negative base. Okay, and then if I do this middle one, without question, somebody in this class is going to write it like this. X plus x minus 2 equals x plus 4. But that's not right. What would we have to do first? Multiply, right? Good. So what we'd have to do is we'd have to make it. Why do I have the smallest eraser in the world? There we go. We have to condense it using multiplication. So log base a of x times x minus 2 equals log base a of x plus 4. And now, since we have one log on each side that's isolated, you You can exponentiate both sides or use that property up above, which says that x times x minus 2 equals x plus 4. All right. Now we can distribute x squared minus 2x equals x plus 4. Subtract x from both sides, subtract 4 from both sides as well. I would get x squared minus 3x minus 4 equals 0. So get everything on the same side if I want to solve that quadratic. And then I should probably do what? I would say. So x minus 4, x plus 1, which gives me solutions of 4 and negative 1. But we need to check for extraneous solutions, which are solutions that you arrive at naturally, but when you plug them back into your equation, do not fit your domain. Okay? So if I plug in 4, am I going to have any issues if I plug in 4? No, because I would have log base a of 4 plus log base a of 4 minus 2 equals log base a of 4 plus 4, which is 8. However, if I plug in negative 1, the first term would be log base a of negative 1, which I cannot have. So I'm going to cross that off. It is extraneous. Extraneous. Okay, so my only answer there is x equals 4. I'm sensing a theme. Wonder if that'll be our only answer here. All right.
Wait, would you explain why negative 1 doesn't work again?
Sure. So we should take our answers and plug them back into our original. So if I do that, I would have log base a of 4 plus log base a of 4 minus 2 equals log base a of 4 plus 2. Or I'm sorry, 4 plus 4. Last one's 4 plus 4. So that's all fine. Log base a of 4 plus log base a of 2 equals log base a of 8. That solution is fine. However, if I plug in negative 1, I would have log base a of negative 1 plus, which like their rate alone is an issue, and then log base a of negative 1 minus 2 equals log base a of negative 1 plus 4. I cannot take the log of a negative number. So this gives me a solution that does not exist. So that's why I can't do negative 1. So anytime you have log of a negative number, now you can get a negative x, but when you plug it back into your log, it has to be positive inside. If it's not, it doesn't exist. Okay? All right. Yeah, okay. Well, let's do this last one, and then I know the bell's going to ring. So we'll have to finish this lesson after your quiz. All right, log base 2 of x plus 1 plus log base 2 of x plus 7 equals 3. We're going to condense the left side. So log base 2 of x plus 1 times x plus 7 equals 3. All right. Now, what I want to do is I need to solve for x, which is inside of a log. Last problem, I just dropped the logs because both sides had a log on it. The right does not. So what I will do is exponentiate both sides with a base of what? 2, because I want to choose a base that's going to cancel out that log. Okay? All right? So I have 2 to the log to all this mess equals 2 to the third power. That cancels that out. What I'm left with is this part here. And on the right side is 2 cubed, which is what? 8. So 2 cubed is what I have on the right side. Otherwise, on the left side, I got to distribute. So x squared plus 8x plus 7 equals 8. And then I should subtract 8 from both sides, giving me x squared plus 8x minus 1 equals 0. Does that factor? So what would I have to use?
Quadratic.
Yep, okay. Your homework is on the last slide. I will look through, because I know I didn't get through everything today, so I'll look through and see if there's anything I'll say, hey, wait until tomorrow. But for now, work on that for your homework, okay?
Would there still be extraneous solutions when using the quadratic formula.
Yep, because you would still because you got that plus or minus in front of the square root. So it's very possible that you would get a negative number, which when you would plug it back into your log might cause an issue.
Okay.
No problem. Be ready for your quiz tomorrow. See you guys then. You too.